Welcome to class number 12. In this class, we will discuss about basic OSPF configuration for dynamic routing protocol. So before going to discuss the OSPF, let's learn a new concept called wildcard mask, which will be used in the OSPF configuration. So normally you know the subnet mask. So subnet mask, we use it to represent the network for an IP. So like usually we represent it with like a /24 or in this format 255.255.255.0. Both are representing the same subnet mask. So when we convert that into bit format, it will be look like this. Like the first 8 octets are ones, second octet is also ones, third octet is also ones, and the last one is zeros. This is for /24. And let's look at wildcard mask. So wildcard mask is exactly reverse of subnet mask. So in this case, we just need to reverse the bit values. Wherever you have ones in the subnet mask, you just need to change it to zeros. Wherever you have zeros, you just need to change it to 1. So if you want to represent /24 in the form of wildcard mask, you just need to represent it in this format. Okay, so it will be like when you reverse this, the value will be this. So means this will be 0, this will be 0, this will be 0, and this will be 255. So both are representing the same. So if you want to represent subnet mask for a /24 network, this is one way, and in the form of subnet mask, it will be 255.255.0, or in the form of wildcard, it will be 0.0.0.255. So these three are representing the same thing. For suppose if we give 10.0.0.1/24 means 10.0.0.0. This network is starting from 10.0.0 and it ends with 10.0.0.255. So either you represent 10.0.0.1 with /24 or with the subnet mask or wildcard mask, it is representing the same network. So these are the quick information about the OSPF. So OSPF is the dynamic routing protocol, and it is categorized as a link state. Okay, so we will see in the next class how the routers advertise to each other about their networks using the link state protocol. But for now, remember that OSPF is link state protocol, and it uses algorithm to find the best route, that is like shortest path first, SPF, shortest path first, to find the best route. And this algorithm is invented by Dice-Cross, the scientist name. So, and the next administrative distance value of any route learned by the OSPF is 110. This is the default AD value of OSPF routes. And OSPF supports IPv4 and IPv6. So currently we are only looking at IP version 4. Okay, and the protocol the OSPF uses to communicate is using IP protocol only. Means it will use the IPs to communicate with each other, and each protocol has some number. So OSPF falls under 89, IP protocol 89. So we did the ping, right? Communication test between two devices. So this ping is based on the ICMP protocol. So this is based on IP protocol number 1. Similar to that, OSPF uses IP protocol number 89. Okay, and authentication is to form neighborship between two routers running OSPF. They need to have, we can provide some passwords. So these are the two types of authentication it can support. So, okay, and next, OSPF uses multicast. So we learned in the previous classes that there are mainly 3 types of traffic. One is unicast. Unicast is one-to-one communication. Next, multicast is one-to-many and broadcast 1 to all. So example for this is ARP request. This will go from one PC to all the devices in the same network. And unicast is the ping test we are doing in the lab from for PC1 to PC2 or something like that. And multicast is one to many, means not all, okay, not to everyone, only to the specified members, but not one machine. So in this communication, one device talking with multiple devices. So OSPF, also in OSPF is a dynamic routing protocol. So every router needs to advertise it routes to other routers in the network. So for suppose if we take this topology, there are 3 routers. If this router wants to advertise whatever the links it has to other 2 routers, it will use the multicast. Okay, for suppose they are connected with a switch. Okay, yeah, so it uses these 2 multicast addresses. So let's come into the OSPF basic configuration and events. So to configure OSPF on any router, first we need to define the process ID. So process ID is nothing but it's like imagine like this is OSPF, something like an application on a computer, right? For suppose if you open Google Chrome on your computer, if you open the task monitor, you can see that each application running on your computer have some process ID. Similar to that, routers also running the OSPF, and each OSPF instance will have one unique process ID. So why do you need to run multiple OSPF? So there will be some scenarios in like service provider environments where you want to configure different instances of OSPF, but for now in the basic classes you don't need to apply 2 or more process IDs in the same router. So for now we will run only single process. Okay, so the process ID can range from 1 to 65535. So you can give any number. For suppose on the R1 you can just give 1 or 2 or anyway until like 65535, any number that does not matter. Okay, so the number should not match between all the routers in the network. So here if you give 1, that does not mean you have to give 1 everywhere in this network. No, you can give any process ID on any router, that does not need to match. Okay, so the OSPF router process ID is unique and local, it is local to the router. That means there is no importance of this process ID, router 1 process ID, from the perspective of any other routers. Okay, and next, router ID. So router ID is something each router in the OSPF, when it advertises it links state to other routers, it will include its ID. Okay, so in OSPF the router ID value will be in the format of IP. It is in the format of IP, but it is not an IP. Okay, it is just an ID. Okay, so don't think that it is an IP address. So we can configure the router ID in the IP address format. So you can, for suppose on the R1 you can just give 1.1.1. So why we need to configure this router ID is, for suppose in this network, if you do show IP route after we configure the OSPF, you will see that some routes are learned by R2, some routes are learned by R4. I'm able to say this because I'm looking at the topology, and from there I can see R2 is will advertise it to R3 and R4 will be advertise it to R3. When you look at the command line, you will see these IPs normally. So if you want to identify uniquely which router is advertising those routes, it's better to always give router ID manually. Okay, for suppose in this topology I will just use router IDs like this way. For router 1 I will do 1.1.1, router 2 I will do 2.2.2, router 3 I will do 3.3.3. So if I run show IP route command anywhere, and if I see some routes are learned by 3.3.3 means that I can simply imagine that okay, those routes are advertised by R3. Okay, so if you don't configure router ID value manually, router will select automatically and it will choose the highest interface in this topology. So if you don't configure the router ID as 1.1.1, so it will choose the highest IP address. So in this case it has two, one is 10.0.0.254, another is 12. So 12 comes after 10, right? So it will choose this one. So it's always better to configure the router ID so that we can easily recognize which router is advertising those routes. Next, how we add routes to the OSPF. So if you want to advertise any routes using the dynamic routing protocol, you need to specifically tell the routing protocol which networks you want to advertise. Okay, so let's say we are on R1. So on R1 there are two networks. One is 10.0.0/24, another one is 12.12.12.0/30. So if you want to R1 advertise these routes to rest of the networks using the OSPF, the only way is you can add network command. Okay, so what you will do is you will go to the router OSPF configuration, you give the process ID, then you will go and type network space, then you will type the network which you want to advertise using OSPF or add it to the OSPF. Okay, so in this case we are using wildcard mask, okay, not network mask. So to represent wildcard mask for 10.0.0/24, we need to give 10.0.0 space 0.0.255. Okay, so this is where we use the wildcard mask in OSPF. So once you give the network command, for suppose in this case you have given the network command like this, what it will do is it will enable the OSPF process on matching interface. So in this case, what is the matching interface? Is this interface Ethernet 12. So now Ethernet 12 we can be listen on OSPF. Also it can advertise its route to other routers. Okay, so in order to enable OSPF on Ethernet 1, you need to do the same command again, but with the network of this one. In this case you will type network, you will add another statement with network 12.12.12.0, then wildcard mask 0.0.0.3 because it's /30. Okay, so next configuration element or concept is OSPF areas. So if we look into this topology, we have 5 routers. Okay, so let's see if there are no areas configured, what will happen. So each router will try to advertise all its network, for suppose let's see these routers are connected like this. So there is a switch in between, and okay, so if you configure OSPF without areas, so all will be in one segment. So what will happen is each router will try to advertise all its routes to other ones. So the same thing happens even if you have 100 routers in similar topology. So what will happen is in the dynamic routing there will be always traffic going between the routers exchanging the routing information. So if you have more routers in the topology and they connected like this, the links will be saturated by this traffic only, this route advertisement traffic only. So the whole bandwidth of this physical link will not be used for the actual traffic it needs to carry, right? For suppose you have 100 PCs here and you have 100 PCs. So we are building OSPF and all these routers and switches to make communication between these two networks, right? But if we are just to exchange these two networks between these two routers, if you are using routing updates and they are utilizing most of the bandwidth on this physical link, it's not efficient, right? So that's why it's mandatory to divide all the OSPF network into areas. So in this case what will happen is whatever the routes are to learn from R1, it will inject it to the area 0. Okay, so in this case area 0 is the like main area in OSPF, also called as like backbone. So it is always good practice to build OSPF topology like this. So in the middle you can take area 0, and all other areas you will attach it to the main area 1 2 3 4 5 6, like hub and spoke model. So what will happen is all other small areas will advertise their routes to the main area, and main area can send these routes to the other areas. Okay, so this way we don't utilize the physical links just for the most of the part for the routing updates. Okay, so there will be less congestion and the network will be more free compared to this topology. So the things to remember is there will be main area and other areas will be connected to the main area. So main area ID will be 0. Okay, so if we take this example, in this case R1 is within area 1, so it's both interfaces are part of area 1. Okay, but in case R2, it has one interface Ethernet 1 in area 1 and another interface Ethernet 2 in area 0. So we call this router as area border router. Okay, we will learn about it more in the next classes, but for now some routers will be having interfaces in multiple areas. Okay, so how do we configure the area? So for this particular interfaces, for suppose if you look at the R1 configuration, once you give network information and then you can add the which area it is part of. Okay, so area ID you will be in the like IP address format, so you can give it in the decimal or IP, doesn't matter. The router will, if you give it in the decimal, router automatically will convert into IP format. For suppose if you give it area 1, router will convert into 0.0.1. Okay, so you can directly give 0.0.1 or you can just give area 1. So on R2, if the command will be little bit different because one interface, this 12.12.0 is on area 1, but 23.23 this one is on area 0. Okay, so this is on area 1, this is on area 0. So when you give the network command, just make sure whatever the network you are defining and that related interface in the correct area. So the basic OSPF configuration to start with is these 3 commands for R1. So we go to the configuration mode by config terminal, then we type router OSPF and we give the process ID, and then we will configure the router ID. Then we will give the network statements to add routes into the OSPF, and we specify which area it is part of. So if you do the similar configuration and all other routers, you don't need to add any static routes and you should be able to ping from PC1 to PC2. So let's see what is the routing status when we don't configure OSPF and just with the interface configurations only. So in this topology, PC1 has 10.0.0.1 and it has gateway of 10.0.0.254, and same for PC2, it has gateway at R5. Okay, 192.168.0.254. So if we go and check the routing table on R1, so in this case we didn't configure the static routing yet and we didn't configure the OSPF as well. So the only routes we expect to see is connected routes based on the interface configurations. So that's what we are seeing here, CC, 2 connected routes. So we should see the similar thing in all other routers as well. So what R2 knows? R2 has only knows 2 connected routes. One is 12.12.12/30 and another one is 23.23/30. So I have taken these IPs so that it will be easy for you to identify which link it is. So I just used 1 2 because I'm using this link between R1 and R2. Okay, so I used 23 here because I am using this link to router 2 to router 3. So this will be easier when we look at the OSPF status comments. It will be easy to recognize which link we are talking about. Okay. And same for R3. R3 has two connections, one to R2, so it should be 23 23, and 1 to 4, so it will be 34 34. Same for R5. So R5 has R4 has one connection to R3, one connection to R5. So 34 34, 45 45, only two routes. Similarly on R5 has one link to the PC with /24.192.168, this one, and another link is to R4, which is 45 45. So far in this topology, all the routers only knows the connected routes. So R5 does not know about this network 34 23 or this 10 network. It does not know. So if we try to ping in this state from PC1 to PC2, what will happen is the packet goes to the gateway, to the R1. R1 only knows two routes. One is for /10/24, another one is 12 12. But this packet, particular ping packet, has the destination IP of 192.168, which is on the other side. So without any routing configuration, R1 will not know anything about this network, and it doesn't know where to send the packet. So that way it will reply back to the whoever sent the request stating that I am unable to reach the destination network. So now go ahead and let's do the OSPF configuration on all the routers. So on R1 we are going to the configuration mode, and the first command we type is process ID, router OSPF 1. So as discussed, process ID can be anything between 1 to 65535. Okay, so you can give any number, does not matter. Then router ID is easy to identify. I am just giving 1.1.1. okay, and network statement. So we have two network statement because we want to advertise these two networks or enable OSPF on these two. So one is 10.00/24 and another one is 12.12.12.0/30. okay, so when I do show run section OSPF, what it will do is, if we just do the show run, it will show all the router configuration including its interfaces and everything. If I just want to see the OSPF part of the configuration, I can use the pipe symbol after show run and include a keyword like section. What this will do is, it will only print the section matching with the word given next to it. Okay, so here if we are giving OSPF, it will only match the OSPF section configuration only. Okay, so in this case we can see network 10.00/24, but when we configure that on the router, as discussed before, we will use like this 10.0.0.0, and then we will give the wildcard mask. So wildcard mask will be 0.0.0.255, then the area statement number 1. Automatically the router will convert into this format. Okay, so but when you try to configure, use this command, network ID subnet mask in the wildcard mask, not subnet mask, then the area and area number 1. okay, so next 12.12.12.0, and then we give the wildcard mask and then the area. So this one is also in the area 1. okay, when we go to the router 2, router OSPF, process ID can be anything, so I'm just giving 1, does not matter, and then the router ID I'm giving 2.2.2, and then network 12.12 area is on area 1, but 23.23 is on area 0. okay, remember that area is different for these two networks because based on the topology, R2 has one interface, Ethernet 1 on area 1 and Ethernet 2 on area 0. So when goes to the R3, these two both are in area 0. In R4, one interface Ethernet 1 is on area 2 and another one is on area 0. And for R5, both of them are in area 2. Okay. So I'm again giving the network command, network, next network ID means the starting address in that network, and then wildcard mask, then area and area ID. So if you want to give R5, let's take example R3. Okay, so this interface, what will be the network statement for this R3 particular Ethernet 2 is command network, then network ID will be, this is 23.23.0. This is the first address in this network, and then the wildcard will be as it is /30.252, and then area. In this case, this interface in area is 0, so I will just give 0. Okay, this exactly will be this one after router taking the configuration. Okay, so once we have OSPF configuration in place, as discussed in the previous slide, if you try to do a ping test, it will work. So when you do the ping test from PC1 to PC2, two things will happen, right? Two packets. One is ping request going from PC1 to PC2, and another one is ping response from PC2 to PC1 for single ping, for single successful ping. Okay, so in this case we have seen 5 pings, means total 10 packets being exchanged. So for the ping request to go from PC1 to PC2, all the routers R1, R2, R3, R4, R5 need to know about this network, because when the ping request is going, destination IP is 192.168.0.1. so as the ping is working, means with the OSPF, all these routers will be able to exchange route information about this particular network. When the replay packet is coming, the same thing. For the replay packet, the destination IP will be 10.0.0.1. So all the routers in this network should know about 10.0.0.1. R1 knows about 10.0 network because it has one interface, but R2, R3, R4, R5 have no idea. But as we configure the OSPF, what will happen is R1 will advertise this network because we have given the network statement with this, right? And R1 has neighborship with R2 OSPF. Okay, now it will advertise, R1 will advertise that okay, I have this network. Then R2 will advertise this to R3. R3 will advertise that information to R4. R4 will advertise that information to R5. So that's how R5 learned about 10 network. Similar thing R1. R1 knows about 192.168 because R5 advertised it to R4. R4 advertised it to R3. R3 did it to R2. R2 did it to R1. Okay. So with OSPF, with just those commands, all these routers were able to exchange about the routing information in this network. With static routes, you had to add static routes on all the routers. Okay, so OSPF configuration will be in the beginning, we need to do some configuration, but to maintain it or adding the routes or removing it will be easier then once we do the basic configuration. So assignment for this lab is build similar topology with the same IP addressing scheme and everything, and configure the OSPF and verify the connectivity from PC1 to PC2. So in the next class I will show you some OSPF commands to verify how the routes being exchanged and some other topics related to the OSPF. Okay, for this lab you just build the lab and verify the connectivity, and we will see how the routes being exchanged in the next class.